Hi, this video is on solving polynomial inequalities, and when we solve polynomial inequalities we prefer for them to be in factored form, and the inequality is going to be with the comparison to 0. That makes it the easiest, so every time you do something like that, this is what you want to try to aim for. These are basic inequalities that I'm going to show you, and I'm going to show you how you do that. So let's take a look at this first one. It's already in factored form. We know it's going to be 0 when x is 1 or when x equals -2. These are the two zeros, and we are going to draw a number line, and we're going to plot our zeros here like that. So what's our next step? Our next step is going to be to pick a number in each interval. We have 3 intervals here, to the left of -2, between -2 and 1, and to the right of 1. And we're going to see what the sign for this expression here, which will tell us the sign for the inequality is. So if I start with the number here, let's say we use -3. -3 minus 1, is negative. -3 plus 2 is negative. Negative times negative gives you positive. Let's pick a number here, for example 0. 0 minus 1 is negative. 0 plus 2 is positive. Negative times positive is negative. So we have negative times negative here. We have negative times positive here. What happens here? Let's pick 2. 2 minus 1 is positive. 2 plus 2 is positive. Positive times positive makes it positive. So this is what we have, right? We're looking for that to be less than 0. So it's less than 0 where we have a negative sign. No equality. So strictly open is going to be from -2 to 1 is going to be the answer. Please remember that you can pick any number you want from the each interval. It doesn't have to be -3, for example, here. The numbers you are not allowed to use are the boundary points, because this is when the inequality is 0, and that's not going to give you any information about the sign. Let's take a look at this next one. So we have 2x minus 3 times 4 minus x. This is going to be 0 when x equals 3/2. This parentheses will be 0 when x is 4. So we have 4 and 3/2. We draw a number line. 3/2 is about 1.5, so it's going to be to the right of 4. Now let's check the signs. So let's use 0 here. So 2 times 0 minus 3 will give us a negative value. 4 minus 0 will give us positive value. So we have negative times positive, thus making the whole thing negative. Number between 3/2 and 4. Let's say we're going to go with 3. 2 times 3 minus 3 is going to make it 2 times 3 is 6, 6 minus 3 is 3, positive, 4 minus 3 is positive, positive times positive is positive. And then we're going to go with 5 here, so 2 times 5 is 10, 10 minus 3 is positive, 5 minus 4 is negative, so negative here. So here we got positive times negative, here we had positive times positive. Right, and we're looking for that to be less than or equal to 0. So where does that happen? It's going to be negative to the left of 3/2 and to the right of 4, and also less than or equal to, so we're going to include the endpoints. So negative infinity to 3/2 included, along with 4 to infinity, like that. Okay, moving on. Next inequality. So we have 3 now. Does anything change? Absolutely not. We still need to identify our zeros, still plot them, and still do sign analysis. So x equals 0 is going to be one number, x equals -2, and also x equals 7. So here's our number line, -2, 0, and 7. So nothing changes. We use exactly the same approach. We pick a number from each interval. Now we're going to have 4 intervals, so it's 4 numbers to pick. And what we have here is, let's go with -3. So negative here, and negative here. 3 negatives make it negative. Number here, let's say -1. -1 here is negative. That makes it positive, that makes it negative. So negative, positive, negative, that's going to be positive. Between 0 and 7, let's go with 1. 1 positive, 1 plus 2 positive, 1 minus 7 is negative, positive, positive, negative, negative. To the right of 7, let's pick 8. Positive, 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 everything's positive, the whole thing is positive. We want it to be greater than or equal to 0. So that's going to happen where? That's going to happen between -2 and 0, including the endpoints. And it's also going to happen to the right of 8. So we're going to go, I'm sorry, to the right of 7, so from 7 to infinity. Next problem. So here we're going to have x equals 5/2. Here we have x equals 1. And here we have x equals -3. -3, 1, 5/2. Okay? And I think you're getting the idea. I'm not going to necessarily pick up values now. But let's see. Well, actually, let's go ahead and do it. Why not? So -4. -4 goes here. -2, 2 times -4, -8, minus 5 is negative. 1 minus -4 is going to give us positive, and that's going to give us negative. So it's actually going to end up giving us a positive sign. Between -3 and 1, let's go with 0. Negative here, positive here, positive here. Negative, positive, positive is negative. Between 1 and 5/2, that's 2.5, so let's go with 2. You're going to see that the sign here is going to be positive. And you will see when you go here, the sign is going to be negative. Looking for that to be less than 0, strictly less. Let's make sure we address it correctly. Do not include the endpoints. Less than is going to be between -3 and 1, as well as 5/2 to infinity. Now this may look like the signs always alternate. Is that actually the case? Because everything we've done so far, the signs go plus, minus, or minus, plus, minus, plus. It seems like they always alternate. Well, let's take a look at this next problem. So we have this. Let's go ahead and find our zeros. So we're going to have x equals 2, x equals 4, and x equals -1, right? And there is a square here, but it's still a 0 at -1. Let's see what happens on the number line. -1, 2, and 4. Let's figure out the signs. See what happens to the left of -1. Let's go with -2, for example. So -2 minus 2 is negative, -2 minus 4 is negative, so negative, negative so far. This is always going to come out to be positive. So negative, negative, positive is actually going to give you a positive sign here. What happens on the other side of -1? Well, let's go with 0. 0 minus 2 is negative, 0 minus 4 is negative, 0 plus 1 is positive, squared still positive, so negative, negative, positive is also plus. Here, let's go with 3. 3 minus 2 is positive, 3 minus 4 is negative, this is still positive, you have a minus here, and you are going to have a plus here. So what happened here? The sign did not change when we crossed -1. That's because -1 is a double zero. It's actually an even multiplicity 0. And when you cross a value like that, you are not going to see a sign change. We want it to be less than or equal to 0. We need to be very careful here because we allow for the sign to be negative or for the value to be 0. To the left of -1 positive, to the right of -1 positive, but at -1 it's actually going to be 0. And because we allow for the equality, we are going to include -1 as a single value, and we're going to unite that with the interval from 2 to 4, which is going to be a closed interval. So it's kind of an interesting solution here because of that. Alright, let's take a look at the next problem. So we have what? We have x equals -5/2, x equals 1, and x equals 5. negative 5 halves, 1 and 5. Alright, let's see what happens with signs here. So let's go with negative 3 here. 2 times negative 3 is negative 6 plus 5 is negative. Negative 3 minus 1 is negative, cube is negative. Negative 3 plus 5 is negative, but we're actually going to turn that into a positive. So negative, negative, positive. That's going to give us a plus. Let's go with 0 here. Positive, negative cube is still negative. Negative square is positive. So we're going to have a negative, positive, positive. That's negative. Right? Over here, 1, 2, let's go with 2. Positive, positive, positive. 3 positives will give us positive. And what happens here when you go 6, positive, positive, and also positive. So that's going to stay. Again, we crossed the double zero here, which was at 5, and our sign did not change. So we can finalize our answer now, greater than 0. So greater than 0, we have to be careful, and you'll see the difference here. Greater than 0 will be negative infinity to negative 5 halves. It's also going to happen here, but at 5, remember, it equals 0. We don't allow for equality here. We're going to have to split it up. So 1 to 5, as long as 5 to infinity. Okay? All right. A couple more examples. I think you should get the hang of it now, and I think I can go a little bit faster with these problems now. So let's see what's going to happen here. Clearly we have 1, but over here we need to factor, because x squared minus 9 can be factored as x minus 3 times x plus 3, which gives us 2 more zeros. We're going to have 3, and we're going to have negative 3. And from this one we're going to get x equals negative half. So we're going to have 4 values total. We're going to have negative 3, negative half, we're going to have 1, and we're going to have 3. Alright. Well, you follow the same procedure. You pick values, put them into the expression, and see what kind of sign you get. Let me do with a couple. We don't have any double zeros here, so there's not going to be any situation where the sign is going to remain the same. Let's start over here, and we can just go ahead and alternate them. So with negative 4. Negative 4 plus 1, minus 1 is negative, cubed is negative. Negative 4 minus 3 is negative. Negative 4 plus 3 is negative, and it's negative here. It's actually going to be 4 negatives, which will give us a plus. And then you can test it. The sign here is going to be minus, and then plus, and then minus, and then plus again. We want it to be greater than 0. So that is going to happen where? That is going to happen on negative infinity to negative 3. No equality, so open, along with negative 1 half to 1, along with 3 to infinity. Okay. And we got one last example. So we're going to have negative 3, we're going to have 4, x squared plus 3. X squared plus 3 on real values is always going to be greater than 0. There is no real value that's going to make it 0. So while it's there and it's part of the expression, you cannot just ignore it completely. It does not have any impact on the sign, since it's always going to remain positive. So we're going to have negative 3 and 4. And you can figure out the signs here. Just be careful. Let's start here, negative 4. So negative 4 plus 3 is negative. 4 minus negative 4 is positive, and this one's positive. This sign is going to be negative. This sign is going to be positive, and this sign is going to be negative. We want for that to be less than or equal to 0. So less than or equal to 0 will be negative infinity to negative 3, closed, along with 4 to infinity. And this is done.